We're about 1,600 feet underground at the world's highest grade uranium mine. This mine alone, Cigar Lake, supplies about 11% of global annual uranium demand.
Half a kilometer beneath the frozen wilderness of northern Saskatchewan lies one of the most astonishing paradoxes in energy history. At Cigar Lake Mine, workers pull from the ground a rock so rich in uranium that a single chunk contains enough potential energy to power hundreds of homes for an entire year. On paper, it looks like a miracle. In reality, it is useless. Straight from the earth, uranium cannot power even a single light bulb. Unlocking its hidden force requires ice fortresses, chemical alchemy, spinning machines faster than jet engines, and secrets guarded like treasure vaults. The chemical beast. Inside Port Hope's conversion facility, chemists prepare for uranium's most perilous shift into uranium hexafluoride gas, UF6. This compound is infamous. It is colorless, invisible, and lethally corrosive. It can eat through flesh, bone, and most metals. Only special nickel alloys can contain it. The uranium oxide from drum 2847 is fed into sealed chambers. At precisely 550 degrees Celsius, fluorine gas is introduced. The reaction is immediate and violent. Bright flames flash inside, gauges spike, pressure climbs. Operators steady their hands on control panels, knowing a single error could render years of work into useless radioactive waste. Finally, the powder transforms. Black uranium oxide becomes colorless UF6 gas. Terrifying to handle, but necessary. Only UF6 turns into a gas at practical temperatures, and only in gaseous form can the tiny weight difference between U-235 and U-238 be exploited. The gas is cooled and pumped into massive steel cylinders, shaped like giant thermoses. Inside these armored vessels lies uranium in its most dangerous yet useful state, ready for the centrifuges. Pellets of power. The enriched powder arrives at a fabrication plant. Here, science becomes almost surgical. In sterile rooms, technicians press the powder into ceramic pellets, no larger than a fingertip. But appearances deceive. Each tiny pellet contains as much energy as a ton of coal. A single reactor core will hold hundreds of thousands of them, enough to power entire cities for months. The inspection process is merciless. Every pellet is examined under microscopes for cracks or density flaws, invisible to the eye. A single defective pellet could force a reactor shut down. Only flawless pellets continue. Approved pellets are loaded into zirconium alloy tubes. Zirconium is chosen because it endures crushing pressure and extreme heat without reacting with uranium. Hundreds of tubes are bundled together into fuel assemblies. These assemblies look like metallic flowers, geometric and precise, their symmetry hiding deadly power. Final inspections include X-rays and ultrasonic scans. Once cleared, the assemblies are sealed into armored casks, built to survive even missile strikes. From here, they travel under armed guard to nuclear reactors worldwide. The Road of Shadows. Drum 2847 is loaded onto a truck. From the outside, it looks ordinary. Inside, it is a fortress. Reinforced steel walls, radiation shielding, GPS tracking, and locks designed to resist even military-grade attacks. The driver embarks on a 2,000 kilometer journey to Port Hope, Ontario. The exact route is classified. Not even his family knows which highways he will take. He sleeps only at secure compounds with armed guards. Stopping at ordinary truck stops is forbidden. The risk of accident or sabotage is too great. Behind him, sealed within the drum, travels something extraordinary. The uranium atoms were forged in a supernova billions of years ago, long before Earth was born. They drifted across the galaxy, merged into the forming planet, and slept underground for ages. Now, for the first time, they ride Canadian highways toward their rebirth as energy. The driver calls it hauling stardust. On the third day, he arrives at Port Hope. Robotic arms unload drum 2847. Paperwork is signed. The driver's mission is complete. But for U-465, the most dangerous transformation is only beginning. The frozen fortress underground. It is December in northern Saskatchewan. The outside air burns at -30 degrees Celsius. Beneath that frozen landscape, hidden in water-soaked sandstone, rests a deposit that has waited in silence for 2 billion years. Geologists call it U-465. Today, its ancient stillness is broken. Cigar Lake Mine is extraordinary. While most uranium deposits contain only 1 or 2% usable material, here the ore averages 16%, 8 times richer than normal. But this miracle is also a nightmare. The uranium lies trapped beneath sandstone saturated with groundwater. Mining it directly would be like tunneling beneath Niagara Falls. Early attempts flooded the mine catastrophically. Many experts declared the project hopeless. Then, engineers proposed an audacious solution. Build a freezer underground. 200 steel pipes were drilled into the earth in a perfect circle around the ore body. Supercooled brine, chilled to -30 degrees Celsius, flowed through them. Over weeks, the surrounding water froze into walls of ice. This artificial permafrost formed an underground dam, holding back millions of liters of groundwater. Inside this icy fortress, miners never touch the ore directly. Radiation levels are far too dangerous. Instead, they sit in sealed booths, guiding remote-controlled drills through camera feeds. The drill heads look like mechanical octopuses, each tentacle armed with tungsten carbide teeth, second only to diamonds in hardness. Slowly, they chew through the sandstone toward the glowing deposit. At 10:47 a.m., one camera shows it. The machine strikes the deposit. U-465, dark and unremarkable to the eye, tumbles into the extraction chamber. Behind thick glass, the operator scoops it up with robotic arms. Air circulation systems flush the mine every 20 minutes, ensuring no invisible radiation lingers. The ore is crushed, ground into powder, and mixed with water into a slurry. By noon, what once lay hidden for eons is loaded onto Truck 47. The ancient rock has begun a journey that will span chemistry, engineering, and physics before it ever produces a single watt of power. The acid test. 3 days later, Truck 47 reaches the uranium mill. If mine was about muscle, this stage is about chemistry. Safety is absolute here. Operators remain behind radiation-proof windows, relying on sensors, gauges, and cameras. The slurry flows into massive tanks. Then comes the acid, chemicals so powerful they can dissolve steel. But their job is precise. They dissolve only uranium, leaving sand and rock behind. It's like mixing salt with sand and pouring in water. Only the salt dissolves, and when the water evaporates, pure crystals remain. At Cigar Lake, the same principle applies, but with acids that could eat through flesh in seconds. Through observation windows, inspectors watch the transformation. Thick brown sludge turns murky yellow, then golden. Stage by stage, the uranium grows purer, leaving waste behind. Next comes the furnace, the most delicate point yet. At 1085 degrees Celsius, hot enough to melt copper, the mixture is roasted for hours. Too hot, and the uranium oxidizes into useless compounds. Too cool, and the reaction fails. Gauges are checked constantly. The tension in the control room is palpable. Finally, a fine black powder emerges. This is uranium oxide, known as yellow cake. To the eye, it looks like soot, but in reality, it is concentrated nuclear potential. Workers carefully pour it into drum 2847, a steel container designed to survive crashes, fires, and even explosions. Each drum can hold uranium powerful enough to run thousands of homes, yet at this stage, the energy is still locked away. Natural uranium contains only 0.7% of the isotope U-235, the key to chain reactions. The rest, U-238, is useless ballast. Until the ratio is changed, this black powder remains dormant. The spinning giants. At dawn, inside a classified enrichment plant, The air vibrates with a low mechanical hum. Here stand thousands of centrifuges, each taller than a man, lined up in endless rows. Their task? To separate isotopes nearly identical in every way. Each centrifuge spins at 60,000 revolutions per minute, twice as fast as the turbines of a fighter jet engine. Into them flows UF6 gas. The heavier U-238 atoms are forced outward by centrifugal force, while the slightly lighter U-235 atoms collect near the center. Alone, the difference is microscopic. But linked together in cascades of thousands, the centrifuges gradually raise U-235 concentration from 0.7% to between 3 and 5%, the golden range for reactor fuel. Operators monitor isotope levels using mass spectrometers sensitive enough to measure atoms. Precision is absolute. One slip can waste millions of dollars worth of uranium. Finally, the target is reached. The enriched gas is cooled and transformed back into uranium oxide powder. The useless ore from Cigar Lake is no longer dead rock, it is reactor-grade fuel. The Cathedral of Atoms. Day 60. At a nuclear plant, technicians in protective suits carefully unload the fuel assemblies. Robotic arms slide them into the reactor vessel. A steel cathedral 40 feet tall and 8 inches thick. Control rods slowly withdraw. Neutrons climb. And then it happens. U-235 atoms split apart, releasing energy and free neutrons. Those neutrons smash into more atoms, triggering billions of chain reactions every second. Heat surges, water boils, steam spins turbines. Electricity surges into the grid. In distant cities, lights flicker on. Hospitals hum with power. Homes glow against the cold. Factories roar back to life. The ore, once buried in sandstone, has become the beating heart of civilization. Conclusion. U-465 no longer exists as rock, powder, or gas. It exists as pure energy, lighting homes, saving lives, and powering industries. At first, uranium seems worthless. Natural ore holds only a sliver of usable isotope. But through ice fortresses, chemical mastery, and centrifuges spinning faster than jet engines, humanity unlocked its hidden fire. One tiny pellet can replace a ton of coal. A single reactor core can power an entire city for months without smoke or carbon. This is not just mining, it is transformation. Proof that sometimes the most priceless things in the universe look worthless until their hidden promise is revealed.